All right, ladies and gentlemen, we're going to go ahead and get started with Chapter 3.3 notes. This is going to be our first day of 2. We're going to talk about the quadratic functions, and then later we'll talk about their models. We're pretty much going to focus in on goal number 1 today. On the backside, we're going to look at goal number 2, again, identifying vertex and axis of symmetry. Eventually, we'll look at graphing these and finding max and mins, and then using the max and min to solve applied problems in the second day. So let's go ahead and get started. We've talked about transformations already, so this is nothing new. So this is just a little refresher. Remember the H value, before we called it B, now we're calling it H. Okay, that's going to move our graph left or right, opposite of what you see. So if you see like X plus 2, it's actually going to move it left. And if you see like X minus 2, it's going to move it to the right. The K value is our up and down shift or vertical shift, and it does what you think. Positive goes up and negative goes down. Last but not least, we're going to talk about this A value. That A value, remember, if it's A is greater than 0, we're going to have a smiley face for these parabolas. And if A is less than 0, then we're going to have a frowny face. So this is what we call transformational form, also known as vertex form. The reason why it's called vertex form is because we're going to have an H and K for a vertex. So as we take a look at example 1, we know we have a parabola and we have a vertical shift of 4. So my vertex now is going up 1, 2, 3, 4. And then we know the pattern is over 1, up 1, over 1, up 1, over 2. 2 squared is 4, so 1, 2, 3, 4. And dun, 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 it's symmetric. We have a nice, pretty parabola. You should be able to label the vertex. Again, there was no H shift, left or right, on a horizontal shift. So that's 0, and then it was shifted up 4. You guys should also know domain and range. Domain is all reals. You can do negative infinity to infinity or the fancy R. And then your range is bottoms up. How low does it go? Does it go down low, down to the flow? No, it goes down to foe. So it starts at foe, and it goes all the way up. How high does it go? Does it go up high all the way to the sky? You betcha. It goes all the way up to infinity. So we take a look at number 2. We see that we have a shift on the inside, and it's opposite of what you see. You have X minus 2, so that's going to be a shift to the right. My vertex now is being shifted over to 2, 0. So 1, 2. And then the pattern is over 1, up 1, over 1, up 1, because 1 squared is 1. Over 2, up 1, 2, 3, 4, because 2 squared is 4. If you want to go over 3 and up 9, you can do that. Over 3 and up 9. There's no problem with that. And then from there, you know your domain is all reals. Again, if you want to do the fancy R, that's fine. And then your range is bottoms up. And it starts all the way at 0 and goes all the way up to infinity. Make sure, again, you guys remember the vertex's Y value is where we're getting our range value. Okay. All right, so we look at number 3 and 4, and you'll see 3 and 4 does not look as nice and pretty as number 1 and 2. We don't have this vertex form where we have a quantity squared plus k, and then I'll ask you guys, well, what do we do? And y'all would chime in, we need to complete the square. So we got to complete the square on these if we're going to use transformations. So we're going to take the b value, we're going to divide by 2 and square it. Now, usually what I like to do is move our constant over. I like to just get that thing out of the way. So again, just a refresher on how we do that. We've got, again, y instead of f of x. We've subtracted 8. I'm going to leave some room. I've got x squared minus 6x all by itself now. And now I am going to, so again, just so you know, this is a y. Okay, I'm going to take my b, divide by 2 and square it. I'm going to take negative 6. I'm going to divide it by 2 and square it. And that is 9er. So if I add 9 to this side, whoa, I got to add it to this side to keep it equal. If it's not keeping equal, we're going to have problems. Okay. So I go ahead and factor this. Factors of 9 that add up to -6 are x minus 3 and x minus 3, or x minus 3 squared. And then we can simplify 9 minus 8, that's 1. And I can subtract that 1 over. So now we have y equals, or f of x equals x minus 3 quantity squared, and then minus 1. Then from there we should know this is a shift to the right and a shift down. So now that's our new vertex. Again, opposite what you see in parentheses, that's 3. And then it is what it is on the outside, that's -1. So I'm going to go ahead and graph 3, -1, 1, 2, 3, down 1. And then up 1 over 1, up 1 over 1. Those are my x-intercepts. Over 2, up 1, 2, 3, 4. 1, 2, 1, 2, 3, and 4. And if they asked you for the y-intercept, I would go over 3 and up 9. And that would help me find that y-intercept if that's something my math lab ever asks. So my domain, again, is all reals. And then my range is bottoms up. Starts here at this y value, which is -1, and goes all the way up to infinity. You guys should have arrows on the ends of your graph so that I know that you know that you know that I know that I know that you know. It goes on forever and ever, and we shouldn't have any issues with that. Okay, so we take a look at number 4, and you'll see that number 4 is very similar to number 3, but you'll see that we have an a value now. So I'm going to start this off pretty much the same thing. I'm going to add over my constant, just so I get it out of the way. And you'll see here in a sec. I get -2x squared plus 2x. And now what I want to do is I want to get rid of this a value by factoring out. So we're going to factor out the a value. You have to do that first. If you don't, you're going to complete the square completely wrong. So we're not ready to take our b and divide by 2. You have to do this first. Okay? So I'm going to go ahead and take out my -2, and I get -2, and then on the inside, I have x squared minus x. And that way, when I distribute back, I would get the same thing. Now I'm going to leave some room. Now I'm ready to complete the square. Now I'm ready to take my b, divide by 2, and square it. So over here, I take -1, I divide by 2, and square it. All right. Well, -1 squared is 1, and 2 squared is 4, so I'm going to add 1/4 here. Now notice where I'm putting that. I'm putting that on the inside of my parentheses. So I have to think about, well, what did I really add in here? What did I really add? Well, think of multiplication. What happens when you multiply -2 times 1/4? Well, I would get -1/2 on this side. -2 times 1 is -2 over 4. That's -1/2. I really added -1/2 on that side. I have to do that over there, or it's not equal. So again, if you need to see that math, again, -2 times 1/4, these guys reduce, and that gives me -1/2. Okay. So I do a little simplifying over here. I get y plus 2.5 or 2.5 if you like decimals. And over here, I've got a factor. Factors of x squared are x and x. I'll just go ahead and show that. And then factors of 1/4 that add up to -1. Look back at what you just did for b over 2 squared. Factors of 1/4 would be -1/2 and -1/2. Negative times a negative is a positive. 1/2 times 1/2 is 1/4. And when you do outers and inners, you're going to get -1/2 and -1/2 to make it a full -1. Okay. So final answer here, when I write this all nice and pretty, I get -2 x to the -1/2 and then squared. And now I'm ready to subtract this 2.5 over. Okay, so finishing up to make it nice and pretty, I'll write down here, I've got y, or g of x equals, I have a -2, x minus 1/2 squared, and then minus 2.5. Okay, looks super scary because there's fractions, but it's really not too bad. If you look at what we did, moved our constant over, factor out our a value, and then completed the square. Be careful when there's an a value, that's a multiplier. What did you really add to both sides? And then from there, We factored. If you're struggling on factors, look back at what b over 2 squared is. Look on the inside. That's going to help you with your factors. Okay. Now, what does this thing do? Well, we have a h value. That moves it this way, opposite of what you see. And then this is my vertical shift. That's the k value. So now we have a vertex that's at 1/2, comma, negative 2.5. So we just kind of have to graph that guy. We're going to go over 1/2 and then down 1, 2.5 boxes. So right in the middle there. And now I'm just going to follow my pattern, but now I've got this a value. So watch out. We also have an a value that's negative 2. Remember, negative is a frowny face, and then I got to stretch it vertically by 2. So normally I would go over 1, up 1. Well, now I'm going over 1, down because it's negative, and down 1 times 2 is 2. So I got to go down over 1, down 1, 2. Over 1, down 1, 2. And then we're going to go over 2. And normally I go up 4. Well, now I got to go down 4 times 2. So that'd be over 1, 2, and then down 1, 2, 3, 4, 5, 6, 7, 8. I'd be off the chart. Okay. Usually with an a value, we usually say about 3 points is all you need, the vertex, and 1 on the left and 1 on the right. If you can do 5 points with an a value, great. This took us just off the chart, but it's not too bad. All right, the next thing we're going to talk about is looking to graph those difficult questions like 3 and 4, but a different way. We're going to use what we call the axis of symmetry formula. Axis of symmetry is basically that line that cuts our parabola in half. And we're going to use that so that we can find out what our vertex is. So we're going to have a line up and down. We're going to plug that value in, and we're going to see what we get. Okay. So here we go. It says find the equation of the axis of symmetry and the coordinates of the vertex of the graph, and then of this given quadratic. Then draw the graph on the graph provided. So as we take a look, we're going to use our AOS formula. That's axis of symmetry for short, AOS. Again, we're going to use x equals negative b over 2a. Now, again, I'm assuming that we're aware what a and b are. A is the number in front of x squared. B is the number in front of x. Okay? So I'm going to go ahead and set this up. I've got x equals negative b. So I have a negative 2. That makes that positive 2. And then 2a, the number in front of x squared is just 1. So I end up with 2 over 2, which we get is 1. Now this is a line, so again, we want to have x equals 1 as our answer. We don't just want 1 as our answer. We want to, show that it is a line. So we're going to go ahead and graph that. I usually do a dotted or dashed line for that. So I'll go ahead and do that in purple here. So I'm going to go over 1. I'm going to use a dotted or dashed line for that, and I'm going to go ahead and label that. Well, somewhere on that line resides our vertex, and this is where we want to plug that in to our equation. So if you need to, do it by hand. 1 squared minus 2 times 1 minus 3, and that simplifies to 1 minus 2 minus 3 is negative 4. So I get a vertex now of 1, negative 4. So I go ahead and graph that. That vertex is right here. 1, 2, 3, 4, down on the axis of symmetry. And then follow the pattern. It's over 1, up 1, over 1, up 1, over 2, 1, 2, 3, 4, over 2, up 4. It's symmetric. And then questions you should be able to answer is domain and range. As we take a look, our domain is always all reals for these quadratics, and then our range is bottoms up, starting at negative 4, going all the way up to infinity. Okay. Now, the only reason I want to talk about number 6 is because it looks super scary because, again, it's a fraction. Don't let fractions freak you out, okay? All we're going to do is our axis of symmetry formula. We got AOS, negative b over 2a. Go ahead and take your b value, negative 7, and then 2a is 2 times 1. So I get negative 7 halves, or if you prefer, negative 3.5, or 0.5. Decimals, fractions, if it doesn't say, I can't take points off or anything like that. I don't normally try to. Okay. All right. Now, I take a look. I take that. I plug it in, and I got to find the vertex. Okay. If I plug it in my calculator for sake of time, you should get negative 0.25. Okay, well, how do I graph that? Well, axis symmetry, I'm going to count over 1, 2, 3.5. So right in the middle between 3 and 4. And down 1/4. So right there. Okay. And then I'm just going to follow the pattern. I'm going to go over 1 and then up a box. Over 1 and up a box. Okay, so that's about 0.75. Okay, and then you can go over 2, 1, 2, and up 1, 2, 3, and 4. Over 2 and up 1, 2, 3, and 4. Right there. Okay, if you need to, you can make a table. You could plug in some values. If you wanted to, you could plug in -3 and -2 and see what you get if you're looking to help yourselves out. Okay, so again, all I did was I plugged this in right here. Again, if you need to see that, negative 0.35, negative 3.5 squared, plus 7 times negative 3.5, and then plus 12, and you should get negative 0.25. Okay. All right. As I take a look at number 7, I've got a nice pretty function here. I've got g of x equals negative 3x squared minus 6x. Again, I'm going to use my AOS formula. I've got x equals that negative b over 2a. In this case, I have the opposite of negative 6, which is 6 over 2a. That's 2 times negative 3. So if I simplify that 6 over negative 6, I get an AOS of x equals negative 1. Okay, so my vertex resides somewhere on that line. It's on negative 1 something. So again, here's negative 1. Nice little dash and dotted line. I'm going to go ahead and label that. X equals negative 1. And now I'm going to plug that in here and here. Okay, please excuse my dear Aunt Sally as you do it. If you do it correctly in your calculator, we should get 3. Okay, so I'm going to count up 1, 2, 3. There's my vertex. Now, don't forget, we have an A value. That A value is right here, this negative 3. Remember what that does. If it's negative, that's a flip and then a stretch of 3. So again, normally I go over 1, up 1. Well, now I'm going over 1, down because it's negative. And now it's down 1 times 3 is 3. That's at 0, 0. Over 1, down 3. If you wanted to, you could go over 2 and up 4 normally. Well, now it's over 2, down 4 times 3. That would be down 12. Now, again, if I have an A value, all we're saying is just graph 2 points, the vertex and a point on the left and right, arrows on the ends of your graphs, and it should be good. Okay, just a rough sketch of what you would see. Again, your domain's all reals, and your range, watch out, when you have a negative, that flips it upside down. So I ask you, how low does it go? Does it go down low, down to the flow? For show, it goes all the way to negative infinity. And you say, how high does it go? Does it go up high all the way to, it stops right there at 3. It's inclusive, so you should have a bracket on there. Okay. All right, ladies and gentlemen, the last one we have for today. As we take a look, it says write the equation in the form y equals a times the quantity x minus h squared plus k from the given graph. So again, things that we need to know is we need to know our vertex, our h and k, and then we got to figure out the a value. Okay, the first thing I always do is find my h and k, and they always give you that vertex right here. Okay, so that's our h and k. So in terms of where we're at, I don't quite know a yet. I'll show you how to do that. I've got x minus h, so minus 1 squared, and then plus k, in our case, minus 5. So the first thing I do is I put in that so that I can find the A value. So that's where we're at now. We got to find A. Use a red marker here. Okay. Now we have lots of different things we can do. If we take a look, they've given us some coordinate points. It doesn't matter which one you choose. This is X, this is Y, this is an XY of our graph. We can just go ahead and plug each of that in. I'm going to probably just use this one right here. It looks like a 0 and a -3 is a nice, easy thing to do. So I'm going to go ahead and plug in -3. I'm going to solve for A. I'm going to plug in that 0 now for X. This is my X. -1 squared, and then -5. So we'll do a little simplifying. I got 5 here. I'm going to add that over. I've got A, 0 minus 1 is -1, and then squared. Well, that's just 1. So I get A is 2. Okay. And if you can tell that by going over 1 and up 2 from -5 to -3, you might not need to do all that algebra. But sometimes they give you some point way up here, and it's a little harder to tell. But that's what I would do is I'd have my vertex, throw in my X and Y so I can find my A. So my final answer is Y equals 2x minus 1 squared and then -5. This is, again, transformational form, also known as vertex form. And if they ever ask for what we call general form, that means they would want it like this. Okay. If they ever ask for general form, that means I would have to FOIL this, distribute the two, and then combine like terms. Okay. I'm not going to ever ask you to do that on a test. I think this will be perfect. Okay. All right, ladies and gentlemen, we will talk to you later. You guys have a great day, and we'll talk and take questions tomorrow. We'll see you again. Bye.